Hello, and welcome to Green Engineering Scholars Advanced Energy Vehicle Design Project by Team Xanthia. This project was executed by three members, namely Adeza Nelly, Andrew Van Fossen, and Maxwell Everett. The AEV project specializes in equipping students with the skills necessary to work as a team and construct an energy vehicle that will travel and be tested in a classroom monorail track system. The AEV itself is a small, autonomous, electric motor and propeller-driven vehicle that will travel across this track system hung from an engineering laboratory ceiling. To begin any sort of project, it is necessary to undergo a brainstorming stage. Here are our three designs we came up with for our AEV. Design A, drawn by Andrew, had lightweight, compact, and aerodynamic characteristics in regard to the AEV. It is also push-based and promoted weight balance. Design B by Max was airplane-inspired with a cross-shaped design that also encouraged the aerodynamic design. Design Z by Adeza was designed to be a small, lightweight vehicle that encouraged center of mass balance and aerodynamics.
After conducting concept screening and scoring tests, we came to choose Design A. This here is an early image of the SolidWorks design. After a considerable amount of discussion and testing, we decided to combine Design A and B in order to improve our AEV. The tests conducted were static and wind tunnel tests, and we measured the system efficiency for our AEV. Our AEV was more efficient when Design A and B were combined, rather than when we only had Design A. This design was a similar but more advanced design of our first AEV. Following the completion of this AEV, we built a second AEV to be tested similarly and compared in efficiency to the first concept. The design was vertical in contrast to our horizontal design and did not include wings. The propellers, Arduino, and battery were attached to the body of the vehicle, and the vehicle itself was much more efficient than our first design. Here in the middle is the improved view of the SolidWorks design. After more testing in different propeller configurations, we realized that the vehicle could be even more energy efficient with less weight. Therefore, we altered the vertical T-shaped design to consist of only the support arm, Arduino, battery, and propellers. Here's the final image of the SolidWorks design to the right. We tested only the last two designs on the classroom track, but here's a short video segment of the finalized AEV operating. As you can see, our newly improved AEV met the operational objectives of checking out the train station and hooking up at the caboose. And by checking out at the train station. To get to this final stage, however, there were some difficulties, including Arduino malfunctions, programming difficulties, and data issues regarding our graphs. Ultimately, all of our problems were resolved in some way, including reversing the Arduino leads on the malfunctioning Arduino, replacing the battery, and updating the GUI code.
During the design process at the end of this project, we have come to realize the extensive work that was put into designing a very efficient vehicle. Ultimately, the amount of energy used was 31 joules, but the amount of designs used to get to that number was 4. Unfortunately, due to the project constraints, some of these designs had to be left out. In total, we had 4 different designs, including one design that didn't meet the constraints that were tested. Like mentioned earlier, the prime focus was being energy efficient while building the code around the lifespan of the battery. From this project, it is safe to conclude that teamwork is an essential part of executing the design projects as well as proper documentation. Without the design process itself, none of this could have been properly accounted for. In conclusion, this project was very beneficial in terms of what we have learned. After going through our 4 designs, we have come to learn what affects the energy efficiency of the vehicle, such as battery life and amount of weight. Overall, teamwork, time management, and organization skills were key to successfully completing the Advanced Energy Vehicle project.